Today we're going to be looking at the trig addition formula. Okay, we're going to be able to use the double angle formula, the trig addition formula, and write expressions in the form a cos theta plus or minus b sine theta in the form of r cos theta plus alpha. Okay, so the addition formula allows us to deal with a sum or a difference. For example, 60 degrees could be written as 20 degrees and plus 40 degrees. Or 60 degrees could be written as 90 degrees minus 30 degrees. Okay, we're manipulating angles here, and the reasons why will become apparent in a moment, okay? But the basics of it is that we are going to write angles as either a product, as a sum or a difference, okay? And this will help us to manipulate and find the answer. So, these are the formulas you need. Okay, they are in the formula booklet, but obviously it's easier if you just know them, okay? That's why today we're going to have them in front of us all the time, but what you will find is that you don't want to memorize them, but then you end up memorizing them, they're in your head, okay? So, this is what we're going to be looking at today. Okay, so do you notice with sine, the answer is sine, cos, sine. Okay, so with sine, it's always sine, cos, and then it's the same sign plus, and then it's cos, sine. Okay, and it's A, B, A, B. Okay, with the minus, it's just sine cos minus cos sine. With cos though, it's always cos sine sine. And then it's the opposite. If that says plus, you have to minus here, sine sine. And then if it's minus cos plus sine sine. And then with tan, okay, it's tan plus tan over 1 minus tan. And then when it's the minus, the sign switch, so it's tan minus tan over 1 plus tan. Okay? Right, so there is a proof of sine. It's not needed for the exam, which isn't needed for. So, how could we prove the result that sine of a plus b equals sine a cos, given that sine of a plus b equals sine a cos b plus cos a sine b, to prove the identity for sine a minus b? So what we're going to do is, instead of writing b, we're going to substitute in minus b. So this is the same as saying sine of a plus minus b, which equals sine of a cos minus b plus, and then we've got cos a and then we're going to have sine minus b. So what's going to happen now? We know, does anybody know a fun fact about cos of minus b? No? We cannot, we could, but if we think about the graph, cos, it's a reflection, okay? It's a reflection in the y-axis. So cos of minus 10 is the same as cos 10. So cos of minus b equals cos of b. So we have sine a, cos of minus b is just cos of b, because the cos graph is a reflection in the y-axis. And then cos A sine minus B, we can take that minus out to have minus cos A sine B. And that's how we've shown, that's how we've proved, given this result, sine of A minus B. Okay? This has come up in an exam before. And where people have got tripped up is the cos of minus B. Now, cos of minus B is the same as cos of B because the cos graph is a reflection in the y-axis. When in doubt, draw it out. Okay? Right, how about cos, given that we have sine of A minus B, how could we prove cos of A plus B? We know that cos of x equals sine lots of pi minus 2 over x. In this case, our x is A plus B. So we're going to substitute in minus A plus B. Okay? So, this is the same as writing sine of pi over 2 minus A plus B. Now, I can rewrite this as sine pi over 2 minus A minus B. But what I want to do is group two of them together, okay? Now, using what we just said, that pi over 2 minus a number is cos of that number, I'm going to group pi over 2 minus a number here. So I'm going to have sine pi over 2 minus A minus B. Okay? So this pi over 2 minus A is now going to be my A, and this minus B is now going to be my B. Okay? So, using the sine rule up here, because this is all we've been given, and we have these two here, so that should actually say, sorry everyone, if I just give myself a bit more room, plus minus B. Remember, because we've only been given this top formula here, so we have to use this one. We're now going to have sine of A, and our A is pi over 2 minus A, cos of B, which is cos of minus B, plus cos of A, which is pi over 2 minus A, sine B, which is sine of minus B. Now, sine pi over 2 minus A, we know is actually, in fact, cos A. Cos of minus B is, in fact, just cos B. Cos of pi over 2 minus A is, in fact, sine of A. Sine of minus B, I can bring that minus B, the minus out here, and then have sine B. So then that's how we've shown what cos of A plus B equals. Okay, first things first, what is tan? Sine over cos. So tan of A plus B equals sine of A plus B over cos of A plus B. Okay, next step. I know what sine of A plus B is and I know what cos of A plus B is, and it is said in the question that I can use this. So this equals sine of A plus B is sine A cos B plus cos A sine B. All of that is over cos A cos B minus sine A sine B. So you're now going to divide every term by cos A cos B. And remember, when we're manipulating functions, as long as we're ensuring that we do the same to every variable, we're okay. So now you can see here, sine A over cos A is tan A, and cos B over cos B is 1. So this is how we get tan A here. Then for this term, cos A over cos A is 1, sine B over cos B is in fact tan B. So plus tan B. Then cos A cos B over cos A cos B is 1. Sine A over cos A is tan A, sine B over cos B is tan B. So that's tan A, tan B. So, given that 2 sine x plus y equals 3 cos x minus y, express tan x in terms of tan y. So it's asking us for tan x in terms of tan y. So what that means is we need to have tan x equals. So, step 1. I'm going to be using the addition formula to rewrite sine and cos. Okay? So, when we are proving and expressing in terms of tan, remember there's more than one way. Some are quicker than others, but you should always get to the same answer. Okay? So sine of x plus sine b. Now if you've got your book in front of you, we're going to have, that's going to be 2 lots of sine x cos y plus cos x sine y equals 3 cos x cos y plus, make sure this goes in brackets, sine x sine y. Perfect. Now I can expand my brackets. So I'm going to get 2 sine x cos y plus 2 cos x sine y equals 3 cos x cos y plus 3 sine x sine y. Some of you might do that in the first step. That's completely fine. Now I want tan. The only way I'm going to get tan is to divide. Okay, and if I think here, if I've got a sine x, how could I get tan? I need to divide by cos. So if I divide this by cos x here, I also, this cos y, I want to get rid of it. I want it to be a 1. So I'm going to divide by cos x cos y. So if I divide everything by cos x cos y, okay, and whatever I do to one term, I have to do to them all. So, I'm then going to end up with sine over cos, That's going to give me tan. Cos over cos is 1. So I'm going to get 2 tan x plus, and then here I'm going to have 2 cos x over cos x is 1. Sine y over cos y is tan y. 2 tan y equals cos x over cos x and cos y over cos y is 1, so that's just 3. And then sine x over cos x is tan x, and sine y over cos y is tan y. So this is where I'm at, but I want it to have tan x equals, okay? So whenever we rearrange and we've got more than one shown, I need to put, so I'm going to put all my tan x's on one side, everything else on the other side. So simple rearranging. So 2 tan x minus 3 tan x tan y equals 3 minus 2 tan y. Is everyone happy how I got that? Okay, and then now because I want tan x on its own, I'm going to factorise tan x on the left-hand side. So tan of x is 2 minus 3 tan y, which equals 3 minus 2 tan y. And then how do I get tan of x on its own? I'm going to divide both sides. So tan of x equals 3 minus 2 tan y over 2 minus 3 tan y. Okay, again, this is very similar to rearranging at GCSE level, but instead of x, we have a trig function. And we just have to rearrange it at the beginning. But this is just manipulating algebra. That's all we're doing, is manipulating. So, exercise 3A. Please can you go to exercise 3A? And no, I don't think it is exercise 3A. I think it's exercise 4A. And can you please have a look at okay, can you do question 2? Question 5. Question 7. Question 9A, C, D. So, what we should really know, okay, and in the UK, if you were doing your A-levels there and this wasn't an international, you'd have to know this, memorise this, okay? They actually memorise this for the GCSE in the UK. So, a few, what you need to know. So you need to know 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, okay? This is what we need to know. And again, you should know that if we converted this to pi, okay, we know that 90 is pi over 2. So 45 is pi over 4. 0 is 0. 60 and 30 is going to be pi over 3 and pi over 6. So again, if we're dealing with radians or, you know, we should be able to know this, okay? And what we're going to have is we're going to find out what sine of x is, cos of x, and tan of x. Okay, let's see if what we can do without using our calculator. First of all, when sine of x equals 0, if you think about the graph, when sine of x equals 0, what does y equal? 0, amazing. What else do we know about sine of x? sine of x has a maximum when x equals 90 and y equals 1. Perfect. Okay, so we know that. How about with cos? Does anybody know with cos, if we look at the graph, cos of x equals 0. What is our y coordinate when cos of x equals 0? It is 1, absolutely. Okay, and when cos of x equals 90? 0, absolutely. When tan of x equals 0, think about the tan graph. When tan of x equals 0, yeah, it is 0. And when tan of x equals 90, yes, because we know it tends to infinity. So, okay, perfect. So we know those, which is amazing. What we need to try and get used to is knowing the rest. So we can fill these in. So if we did sine of 30, we're going to get a half. Sine of 45, we're going to get root 2 over 2. And sine of 60 is, in fact, root 3 over 2. Now, because we know that cos is a translation of sine, okay, it's reversed. So we have a half, root 2 over 2, root 3 over 2. Then tan slightly different. So tan of 30 is root 3 over 3. Tan of 45 is in fact 1. And tan of 60 is root 3. Using a suitable angle formula, show that sine of 15 degrees equals root 6 minus root 2 over 4. Okay, so we have a few key numbers that we like to work with. Okay, we can work with 0, 30, 45, 60, and 95, not 95, and 90. Is there a way we can make 15? Absolutely. 45 minus 30, okay? So, this is going to be sine of 15, I can rewrite that as sine of 45 minus 30. Okay, we have a double angle formula. We have a look in our books because we haven't memorised these yet. And this is actually going to be sine, remember our A is 45 and our B is 30. So we're going to have sine of 45 minus 30 is rewritten as sine of A, which is 45, cos of B, which is 30, minus, cos of A, which is 45, sine of B, which is 30. And again, we're just using the formula to fill it in, aren't we? Okay, all we're doing is substitution, nice and easy. Now, using that picture you've just taken on your phone, okay, you know that sine of 45 is root 2 over 2. Cos of 30 is root 3 over 2. Minus cos of 45, which is root 2 over 2. And sine of 30, which is a half. So all I've done now is written the exact values of sine or cos. Okay, and now I'm going to multiply, expand, and take away. So here we have a fraction problem now. So root 2 times root 3 is in fact root 6 over 4. Minus root 2 times 1 is root 2 over 4. Lucky for us, they have the same denominator, so we've not got to multiply by anything. So we can just write root 6 minus root 2 over 4. Therefore, shown. Okay, so, second question. Given that sine of A equals minus 3 over 5, and 180 degrees is less than A is less than 270, and that cos B equals minus 12 over 13, find the value A of cos of A minus B and B tan of A plus B. Okay? So, step 1. Let's do part A first. It's told us cos A minus B. Okay? So, cos of A minus B equals, and let's write it down, what does it equal? Cos A cos B plus sine A sine B. Okay? So, we've got that written down. Now, it tells us that cos B equals, and we have a sine A. Okay, well, hold on a minute. I know that cos B is minus 12 over 13. So everywhere it says cos B, I'm going to write minus 12 over 13. But I have sine A, great. I don't have a sine B yet. And I don't have a cos A. But that's okay, because I know a formula that can help us, okay? I know that sine squared plus cos squared equals 1. I'm going to use that to then find the opposites. So, I know then that if sine squared of A plus cos squared A equals 1, okay, that means that cos of A equals the square root of 1 minus sine squared A. And I could write that if sine squared B plus cos squared B equals 1, that means sine B equals the square root of 1 minus cos squared B. Now, I have been given sine A, which is minus 3 over 5, so cos A. So now I'm going to have cos A equals the square root of 1 minus 3 over 5 squared, because that's what sine of A equals, minus 3 over 5. Okay, I'm going to square it. So that means that cos A is 1 minus 9 over 25, which is 16 over 25 square rooted, which is 4 over 5 plus or minus 4 over 5 when we do the square root, okay? And then we get plus or minus 4 over 5. But this is where we have to think about the graph again. We always refer to the graph. It says 180 degrees to 270 degrees, okay? If we draw the cross graph, okay, we know this is 180. This is, in fact, 270. Okay, so it's got to be in between here. So do we want a positive or a negative 4 over 5? We have a look. The graph is in between here. So we can see the graph is here. Use a different colour. The graph is here, is where we want it. And this is negative. So we want to have the negative 4 over 5. We're going to reject the positive 4 over 5. So we're going to reject the positive and we're in fact only going to keep the negative. So that means that cos of A, in fact, just equals negative 4 over 5 because of the interval that it's in. It's in between 180 and 270. Okay, so now we figured out cos of A. Perfect. Now we're going to do the same thing and find sine B. So, sine of B equals the square root of 1 minus cos squared of B. Now, it tells us that cos of B is minus 12 over 13, so it's minus 12 over 13 squared. Okay, so we're going to get sine of B equals 1 minus 144 over 169, which is 25 over 169? 25 over 169 square rooted, which is in fact plus or minus 5 over 13. Okay, again, use your calculator for that. Right, now let's think of the sine graph. I think the sine graph is here. This is 180. Here is 270, okay? And if we look at the graph, between 180 and 270 is a negative value, okay? So we're going to take the negative value. Yeah. So we're going to have negative, so sine B equals negative 5 over 13. I'm so sorry, this is so messy. Okay, right. Now we have our rule and we have every single variable now. So now we can substitute in. So we know that cos of A minus B, okay, equals cos A, which it told us we just figured it out, is minus 4 over 5. Actually, let's highlight everything. Okay, sine of A is in the question. Cos B is in the question. Cos A is in the question, we figured out, and sine B we figured out. Okay, so there we are. I've highlighted them so we can see them. Okay, so it's cos A, which is minus 4 over 5, multiplied by cos B, which is in the question, minus 12 over 13. Then add sine of A, which is in the question, minus 3 over 5, multiplied by sine of B, which we just figured out, minus 5 over 13. Okay? So then what's going to happen is cos of A minus B equals 12. We're going to get 48 over 65 plus 15 over 65 which equals 63 over 65. So this is the value of cos of A minus B. It's 63 over 65 within the interval of 180 and 270. Okay, I'd just like to point out, in the book, the textbook, it actually says that the angle of B is obtuse. If B is obtuse, it means it's in the interval of 90 and 180, which when we're figuring out sine, we would in fact take the positive value, okay? What I've done in this question is I've used the same interval, that B is between 180 and 270, which gives us the negative 5 over 13. So for the question that we've answered, this is completely correct. So for part B, we're going to stick with the same interval again, that 180 degrees is less than B, which is less than 270. So for this question, that's what we've done, okay? So again, we're saying that 180 degrees is less than B, is less than 270 degrees. So using that same interval, we already figured out what the missing values were, so sine B and cos A. So we always need to write down that tan of A plus B, and using our formula, we know that that's equal to tan of A plus tan of B all over 1 minus tan A tan B. So we already know that sine of A equals minus 3 over 5. We know that sine of B equals minus minus 5 over 13, we know that cos of A equals negative 4 over 5 and cos of B equals negative 12 over 13. That was from earlier, and 2 of them we got in the question. We know that tan is silical, so tan of A is going to equal sine of A over cos of A. So tan of A is going to equal minus 3 over 5 over cos of A, which is minus 4 over 5, which just equals 3 over 4. We know that tan of B is sine B over cos B, which is minus 5 over 13 over minus 12 over 13, which is in fact 5 over 12. Now we have those values, we can substitute them in. So that means then that tan of A plus B equals tan of A, which is 3/4, plus tan of B, which is 5/12, all over 1 minus tan of A, 3/4, multiplied by tan of B, which is 5 over 12. Okay, and then if we figure that out, 3 over 4 in terms of 12 is 9 over 12 plus 5 over 12 is 14 over 12. All of that over 3 times 1 minus 15 over 48, which equals 14 over 12 over 33 over 48. Did anyone get an answer? 8 over 9, which equals 8 over 9. Yeah, no. 56 over 33. So that's what tan of A plus B equals. 56 over 33. Right, so test your understanding. Now, remember, we like to use the numbers 0, 30, 45, 60, and 90. Okay, so cos of 75. How can I make 75? 30 and 45. So, 30 plus 45. So I know I'm going to have to do cos of 30 plus 45. So this is going to be my cos of A plus B. We know that cos of A plus B is cos of A, so cos A cos B minus sine A sine B. So this is going to equal cos 30 cos 45 minus sine 30 sine 45. Now, we know what these are, okay? And if you don't know what they are, you can put them into your calculator. So it's 1 over root 2 times root 3 over 2 minus 1 over root 2 times a half, which I think we did this example earlier. Root 6 minus root 2 over 4. Perfect. And then tan of 75, again, we're going to use the same. So we're going to have tan of 30 plus 45, which is going to give me tan of 30 plus tan of 45 over 1 minus tan 30 tan 45. Now, of course, you could put this into your calculator, but you're not going to get the marks, okay? Because it's one of those show that questions. Now, we could do this way. Another way you could do it is, you know that tan of 75 is also sine of 75 over cos of 75. Okay, so you could use the sine and then divide that by the cos. Either way is fine. So then what you're going to have, we know that tan of 30 is root 3 over 3 plus 1 divided by 1 minus root 3 over 3 times 1, which is in fact going to give me, when I put that in my calculator, 2 plus root 3. Again, you could have done this a slightly different way, which I'll show you on the next page actually. Here we go. So on the next page, they've done sine of 75 over cos of 75. Okay, because we already figured out cos of 75, so you can already use that. And you just use sine of 75 and then divide the two values together to get the answer. Okay, either way, it's the same. Okay, so now I have a bit of a challenge for you to do. Once you've done the challenge, you are then going to move on to some of the questions in the textbook. So this was a question in 2013. So it says, given that 2 cos of x plus 50 equals sine of x plus 40. So step 1, write cos of x plus 50 and sine of x plus 40 as the expanded addition formula. So we know that we're going to have two lots. If this is my A and B, okay, cos of A plus B is cos x cos 50 minus 2 sine x sine 50. Okay, so that's what the cos equals. And that actually equals sine of x plus 40. That's sine of A plus B. So I'm going to get sine A, which is x, cos B, which is 40, plus cos A, which is x, sine B, which is 40. Okay, so that equals that. Okay, what am I now going to do? Okay. What do we know? Again, if we have a look, we have a cos 50, a sine 50, okay? Now, what do we know about the relationship between sine and cos? Okay, we know that sine of x equals cos of 90 minus x, and we know that cos of x equals sine of 90 minus x, okay, because we know it's a translation, don't we? Okay, so this is quite challenging here, because actually, so that means that sine of 50 is in fact cos of 90 minus 50, which is cos of 40, and cos of 50 equals cos of 90 minus 50, which is, sine of 90 minus 50, which is sine of 40. And the reason why I've done that is because we have tan 40. Okay? So, we need to make sure that we then rewrite everything that we've just learned. So, we're going to have 2 cos x. Cos 50 is now, in fact, sine 40. Minus 2 sine x. Sine 50 is, in fact, cos 40 equals sine x. Cos 40 is, in fact, sine. No, we don't. No, we already got 40. So that's cos 40 plus cos x sine 40. Okay, so now we've got to divide by something to make sure we get tan, okay? And the only thing we could divide by is going to be cos x cos 40. So I'm going to divide everything by cos x cos 40. Yeah, that'll give me tan. Cos x cos 40, that'll give me tan. Yep. Cos x cos 40, that'll also give me a tan. cos x cos 40. Brilliant, that'll give me tan 2. So what we're going to have is 2 cos x sine 40 over cos x cos 40 is in fact 2 tan 40. Minus 2 sine x cos 40 over cos 40, so that's just 2 tan x, equals sine x over cos x, and then the cos 40 is going to cancel, so that's tan x, plus cos x sine 40 over cos x cos 40 is just going to be tan 40. So now I need to rearrange. So if I move the tan 40 to the left-hand side, I'm going to have tan 40 and all the tan x's to the right-hand side is 3 tan x. Okay, I'm going to rewrite that because in our question they've got tan x on the left-hand side of tan 40, and then to find 1 tan x, I'm going to divide by 3. So tan x equals a third of tan 40. Okay, so you need to do exercise 4B, question 3, 5, 6, part B and C, and question 9, part A, B and C. The angle in halves, okay, which is really amazing. Now, how they've derived this formula is actually by using the addition formula, but instead of having sine of A plus B, they've got sine of A plus A, because A plus A is in fact 2A. They've substituted it in and then simplified. Now, cos of 2A, the identity is cos squared A minus sine squared A. But as you know, we know that cos squared A plus sine squared A equals 1. So by rearranging this and substituting in, we then managed to make 2 other identities. And then with tan, again, instead of writing A plus B, it's A plus A, and then when we substitute in, we're going to get this formula. Okay, so nice and simple. So you can derive these formulas if you need to. So what we're going to do is we're going to take a look at a few examples. So if we have a look at part A, it says, use the double angle formula to write each of the following as a single trigonometric ratio. So at the minute we've got 2 trigonometric ratios, we just want a single. So I have cos squared and sine squared. So if I look on here, it actually matches cos of 2x, which is cos squared x minus sine squared x. So we know, oh, sorry, I don't know what happened there. So in this case, this is going to give us cos of 2x, okay, equals cos squared x minus sine squared x. So you can see here it matches up. Our x is in fact 50. So we know that cos of 2 lots of 50 equals cos of 100, which is cos squared of 50 minus sine squared of 50. So our actual answer is cos of 100. And obviously we're working in degrees. Then for the next one, we have 2 tan of pi over 6 over 1 minus tan squared pi over 6. So if we have a look, this matches this one here. Our x is in fact pi over 6. So we know that this is going to equal tan of 2 lots of pi over 6, which equals tan of pi over 3. Then for the last one is slightly different because we have 4 sine of 70 over sec of 70. So we need to do a slight bit of rearranging. So we know we have 4 sine of 70 multiplied by, we know that sec is 1 over cos. So multiplied by 1 over, sorry, it's not multiplied at all. And this is cos
So 4 sine 70, and then it's divided by sec of 70. So we're going to have 4 sine of 70 divided by 1 over cos of 70, okay, which we know is stay, change, flip. So 4 sine of 70 multiplied by cos of 70. So this is actually going to simplify to 4 sine 70 cos 70. Okay, so if we have a look what rule this matches to, and this matches to this rule here, okay, sine of 2x equals 2 sine x cos x. But here we've got 4 lots, so we need to factorize out of 2. So we get 2 lots of 2 sine 70 cos 70. Now we know that we could rewrite 2 sine 70 cos 70 as sine of 2 lots of 70, which is sine of 140. So we have 2 lots of sine 140, which we're then going to just write as 2 sine 140. So here are some more examples of how we might use the double angle formula. So given that x equals 3 sine theta and y equals 3 minus 4 cos of 2 theta, eliminate theta and express y in terms of x. So we're going to need an equation where y equals something with x in. So first of all, it's given us x equals 3 sine theta. So we could rearrange that. And if we divide both sides by 3, we get sine theta equals x over 3. Okay. Then for the second one, we have y equals 3 minus 4 cos of 2 theta. Now we have a sine here, and we want to eliminate theta. So when I'm choosing which double angle formula I need for cos of 2 theta, I'm going to look for the one with just a sine in, because we've already been given what sine is. So I'm going to use 1 minus 2 sine squared theta. So I'm going to have y equals 3 minus 4 lots of 1 minus 2 sine squared theta. So I'm going to get y equals 3 minus 4 minus 4 times minus 2 is plus 8 sine squared theta. So y equals 3 minus 4, which is minus 1, plus 8 sine squared theta. Now, we know that sine theta actually equals x over 3, and we know that sine squared theta is, in fact, sine of theta all squared. So I'm going to substitute that in. So therefore, y equals minus 1 plus 8 lots of x over 3 squared. So I'm going to just simplify that slightly. So y equals 8x squared over 9 minus 1. So now we've eliminated theta and we've expressed y in terms of x. Given that cos x equals 3/4 and x is acute, find the exact value of sine 2x and tan 2x. So what equation do I know that relates cos and sine, so that if I have cos, how could I find sine? Forget that it's a double angle formula for a moment. I just know that to find tan, I need sine over cos, and for sine, I need to find cos. I do know that cos squared x plus sine squared x equals 1. So, using that to begin with, cos squared x plus sine squared x equals 1. So that means sine of x equals the square root of 1 minus cos squared x. So sine of x equals the square root of 1 minus, we know that cos of x is 3/4, so that's going to be 3/4 squared. So sine of x equals root 1 minus 9 over 16, which is root 7 over 4. Yes, it is. Okay, root 7 over 4, but again we have a plus or minus. Now, it tells us that x is acute. So if I think about x being acute, for the sine graph, that means that we're going to have x is less than 90, which we can see here, all positive values. So we're going to reject the negative, and we're going to use sine of x equals the positive root over 4. Okay, so now we have what cos is, we have what sine is, we can get back to the actual question. So we want to find, so part A, we want to find sine of 2x. Now sine of 2x, we know it is 2 sine x cos x, okay? So this equals 2 sine x cos x, which is going to equal 2 lots of sine x is in fact root 7 over 4, and cos x is in fact 3 over 4. So we're going to have 6 root 7 over 16, which is in actual fact 3 root 7 over 8. So nice and simple. Now we've got all the information. Okay, part B, we need tan 2 of x. Now, when we look at tan 2 of x, the formula is 2 tan of x over 1 minus tan squared x. So that equals 2 tan x over 1 minus tan squared x. So we need tan of x. Luckily, we have sine of x and cos of x. So if we just do a little side note, so tan of x equals, silly cow, sine over cos. Sine of x we just worked out is 3, sorry, that was the sine of 2x. So root 7 over 4 divided by cos of x, which we know is 3 over 4. So I'm going to get root 7 over 3. Perfect. Now we've got that, we can substitute in. So tan 2 of x is going to equal 2 lots of tan x, which we know is root 7 over 3. 2 lots of root 7 over 3 over 1 minus tan squared x, which is root 7 over 3, all squared. I'm going to substitute that into my calculator, and I'm going to get 3 root 7. So nice and easy, and that is a few more examples on how we solve equations. Sorry, we're not solving equations. How we write equations using the double angle formula. So, exercise 4C. Please can you do questions 6, 13, 14, 15 and 16. Moving on to solving trigonometric equations. So what we're going to do now is we're going to be solving the equations just like we normally would, but now that we've learned about the addition formula and the double angle formula, we may need to use that first to rearrange the equation into a form that we can then solve. So let's have a look at this equation. Solve 3 cos 2 of x minus cos x plus 2. Now, at the minute, I'm really not sure how I'm going to solve that. So I'm going to need to manipulate this. Now, when I look at this, the first thing that pops to my head is, I wish this was a quadratic. Well, fear not. We can make this into a quadratic because we know that cos 2 of x can be written in terms of cos squared. So it's 2 cos squared x minus 1. So I'm going to substitute that in. And I'm going to have 3 lots of 2 cos squared x minus 1 minus cos of x plus 2 equals 0. Expand out, I'm going to get 6 cos squared x minus 3 minus cos of x plus 2 equals 0. I'm just going to rearrange and simplify. So 6 cos squared x and then minus cos x minus 3 plus 2 is minus 1 equals 0. Now going to factorize, and because we have a quadratic, so we're going to have 3 cos of x, 2 cos of x, and this is going to have to be minus 1 and plus 1. This equals 0. So now for each bracket to equal 0, I'm going to have cos of x equals negative a third, and cos of x equals positive a half. Perfect. So remember, I completely forgot to say this because I was overwhelmed by the quadratic, but look at the interval, we're in degrees. Calculator needs to be in degrees, please. So cos of minus a third and cos of x equals a half. So I'm going to use the cast diagram. So first up, okay, so we know this is 0, 180, 90. So cos of x equals a half. We know that the inverse is 60 degrees. So cos to the minus 1 is 60. So we know this is 60. We're going to reflect it here. So we know this is 360 minus 60, which is also going to give us 300. Perfect. And then we're going to have cos of x equals minus a third. Minus a third, when I put that into my calculator, I'm going to get 109.5. Okay, which is roughly here. So it's this angle. And then I'm going to reflect it in this line. So if I do 360 minus 109.5, I get 250.5. Now, what I always like to do at the end of these types of questions is I like to write them out in ascending order. So x can equal 60, 109.5, 250.5, and 300 degrees. So here are a few more examples. Again, I suggest you just try these on your own before you watch me go through them. So we know that 3a can be written as 2a plus a, okay, and we're going to use that fact to help us with this question. So show that sine of 3a equals 3 sine a minus 4 sine cubed a. Okay, so first things first. Sine of 3a is going to be rewritten as sine of 2a plus a. So, using the formula of sine of a plus b, we're going to get sine of a, which is 2a. Now, I know it says 2a and a, but you've got to remember this is our a, this is our b. So sine of a, and when I refer to a in this case, I'm referring to this one, and when I refer to b, I'm referring to this one. So when I read the formula out, I have sine of a, back to black, cos of b, which in our case is a, plus cos of a, which in our case is 2a, sine of b, which in our case is a. So this is just substituting into the formula. Now, we also know that it wants us to show that we have at the end 4 sine cubed and sine. So we have 2 double angles here. We need to make sure for cos, because we have 3 different identities, that we're just using the one that contains a sine. So then, sine of 2a. We know this is a double angle formula and this is a double angle formula. So we're going to also use sine of 2a equals 2 sine a cos a. We're going to use cos of 2a equals 1 minus 2 sine squared a. So instead of writing sine of 2a, we're going to write 2 sine a cos a and then cos a, plus, and instead of writing cos of 2a, we're going to write 1 minus 2 sine squared a, and then we're going to have sine a. Now I'm going to expand and simplify. So 2 sine a, and then cos a is in fact cos squared a. Now we actually know that cos squared a equals 1 minus sine squared a, so I'm going to substitute that in a second. And then I'm going to get plus sine a minus 2 sine cubed a. And that's by expanding 1 times sine a and minus 2 sine squared times sine a. So again, I'm now going to substitute in for cos squared a. We're going to substitute in. So this equals 2 sine a, and cos squared we know is 1 minus sine squared a. And then we still have plus sine a minus 2 sine cubed a. So if I expand, simplify, I'm going to get 2 sine a minus 2 sine cubed a plus sine a minus 2 sine cubed a. Okay, so if I collect all my sine a's, I've got 2 sine a plus sine a, which is 3 sine a. Got minus 2 sine cubed a minus 2 sine cubed a is minus 4 sine cubed a. I think that's what it asked for. Yep. Okay, so therefore proved. Okay, and I've also kept a note here of the identities I've used. And I think whilst we are using these types of questions, we should write these down. It will help us as well with spotting patterns and what to use. Okay, now part B says hence or otherwise. If it says hence or otherwise, what we need to do is use what we've just found out. So, if I have a look at what was in question 1. Question 1 said sine of 3a equals 3 sine a minus 4 sine cubed a. Okay. Oh, and again, look at our interval. We're in radians now. Make sure you calculate it straight in radians. And then they've told us 16 sine cubed theta minus 12 sine theta minus 2 root 3 equals 0. Okay, so I'm going to look at what they gave us in question 1 and what they've done in question 2. Now, straight away, I can see we have a sine cubed, sine theta, sine theta. Okay, the signs are different, but 16 and 4 has been multiplied by 4, 3 and 12 have been multiplied by 4, but this is now a negative, so it's been multiplied by minus 4. So what I'm going to do is, for this second equation here, I'm going to take out a factor of minus 4. If I take out a factor of minus 4 multiplied by what is 16 sine squared theta is in fact minus 4 sine, cubed, not squared. And then minus 4 times what is minus 12 sine theta? That is in fact plus 3 sine theta minus 2 root 3 equals 0. I'm just going to rearrange the inside of this bracket so you can see. You're going to have minus 4 and then 3 sine theta minus 4 sine cubed theta minus 2 root 3 equals 0. Now, we know that 3 sine theta minus 4 sine cubed theta here can be written as sine of 3 theta. I know, I can't believe it. So, minus 4 bracket sine of 3 theta close bracket minus 2 root 3 equals 0. Okay, this is really lovely now actually, because now I can add 2 root 3 to both sides. So I'm going to get minus 4 sine root 3, and we're back here to pure 2 equals 2 root 3. To get sine of 3 theta on its own, I'm going to divide by minus 4, so we're going to get minus root 3 over 2. Perfect. Okay, so now we're ready to solve this. Our interval was between 0, theta is less than 2 pi. So our interval was between 0 is less than, theta is less than 2 pi. Did it equal them? No. Okay, and then now if our interval is between 3 theta, we're going to multiply everything by 3, we're going to have 6 pi. So So that means that 3 theta equals inverse sine of minus 3 root 2, which is in fact 4 pi over 3. But as you know, we're going to use the CAS diagram to actually see how many times. So if we think this is 0, 2 pi, pi. So 4 pi over 3 is pi over 2. So 4 pi over 3 is going to be about here, isn't it? Because it's 1 1/3 pi. Okay. So this whole angle is 4 pi over 3. 3 over 3 pi is going to be here. So this must mean that this little angle here is in fact pi over 3. So now, obviously CAST. So now we know that's pi over 3, and we're going to have to take away, if we reflect it in the vertical line here, so this is going to have to be pi over 3. Okay, so now we start at 0. Okay, so we start at 0, we go round. The first time we're going to intersect is 4 pi over 3, because if I add pi over 3 to pi, I get 4 pi over 3. Perfect. Then I continue to go round, and the second time I hit it is here, which is 2 pi minus pi over 3, which is in fact 5 pi over 3. Then I continue to go round. Now remember, now when we go round, we're starting here. This is now we're starting at 2 pi. So we get here, so this should be 3 pi. So I've got 3 pi plus pi over 3, which is 10 pi over 3. And then I continue to go round, stop here. Remember now we're getting close to 4 pi. So 4 pi minus pi over 3, 11 pi over 3. And then we continue to go round because our interval stops at 6 pi. All the way round, so that's 4 pi. This now becomes 5 pi. So 5 pi plus a third, 16 pi over 3. And then we carry on going round. Now remember, this is now 6 pi, so we're going to do 6 pi minus a third, which is 17 pi over 3. And then we stop because we reach 6 pi. So now to find out what theta is, I need to divide all of these by 3, which is going to mean they're all going to be over 9. So here we have all of our solutions. Oh, there we go. Okay, nice and simple question. Right then, next one. Here we have solve 4 cos of theta minus 30 degrees equals 8 root 2 sine theta in the range of 0 is less than or equal to theta is less than 360 degrees. Step 1. What is step 1? Degrees. Put your calculator into degrees, please. Okay, step 2. So here we have the addition formula. So remember, this is our A and this is our B. So we're going to have 4 and we're going to have cos A, cos B, so cos theta, cos B, which is 30. And then it's a minus, so it's a plus 4. I mean, you could always, if you wanted to, put the brackets, then expand it. But and then this is going to be sine A, sine B. So that's sine theta, sine 30. And this equals 8 root 2 sine theta. So what am I actually going to do now? Well, I know, first of all, that cos 30 is actually root 3 over 2. So everywhere there's a cos 30, I'm going to write this here. Okay, and I know that sine 30 is in fact a half. Okay, so if you know the exact values, always substitute them in. So we're going to get 4 cos theta times root 3 over 2 plus 4 sine theta times a half equals 8 root 2 sine theta. So now what I'm going to do is I'm going to multiply, simplify each one of these. Normally I'd do this in my head and I wouldn't write the step down, but I think it's good for you to see how we've done that. So root 3 over 2 times 4 is going to be 2 root 3 cos theta plus 2 sine theta equals 8 root 2 sine theta. So now what I'm going to do is put my sines on one side, have my coses on the other, and then I have sine and cos. Of course, it's going to be tan. So 2 root 3 cos theta equals 8 root 2 sine theta minus 2 sine theta. If I factorize out a sine theta, I'm going to get 2 root 3 cos theta equals 8 root 2 minus 2 lots of sine theta. Oh. I'm now going to divide both sides by cos. 2 root 3 equals 8 root 2 minus 2 sine theta over cos theta, which we know are going to cancel to give me a tan. And again, I'm writing more steps than I normally would, because I'd normally straight away just divide by this number and divide by cos, so that we're going to have, it would just save time, but tan theta, I want you to see all the steps, and then 2 root 3 over 8 root 2 minus 2 equals tan theta. So now I'm going to put that into my calculator, and tan theta equals 20.4 degrees. Again, we have this in the interval, so I'm going to draw my CAS diagram. Okay, 20.4 degrees is here. I'm going to reflect it here, so this is 20.4. We know this is 0 and this is 180, so I'm going to have to do 180 plus 20.4, because if I start at 0, go all the way around, and that is the only other time it will intersect between 0 and 360. So we're going to have 180 plus 20.4, which is 200.4 degrees. Okay, perfect. So it's always good, just some little tips, to write down what you're substituting in. Okay, write down your exact trig values. Okay, what I would like you to do is stop, pause this and test your understanding and see how you finish these questions. Here are the answers. Please check through them and make sure that if you watch out for the plus and minus when we're square rooting here. Okay. Now you need to move on to exercise 4D and you need to do question 2, question 8, question 11, question 12 and question 14. So here's a sketch of y equals 3 sine x plus 4 cos x. What do you notice about this sketch? Have a think about this, please. So you're right, it has been translated and it's been stretched. So if we think about a function, f of x, if it's been translated, we know we're going to have f of x plus or minus a number. I'm just going to call this a. And then if it's been stretched, we know then that it's been multiplied. The whole function's been multiplied. So I'm going to write b on the outside. Now, using trig, we have another identity here. We can actually represent this equation in the form y equals r sine of x plus alpha, where alpha is, how much we translate it by. Okay, so if we have a graph in degrees, we would put degrees here. If it was in radians, we put radians here. Normally, we'd write it in terms of pi as well. So a typical question would be, put 3 sine x plus 4 cos x in the form r sine x plus alpha, given alpha in degrees to 1 decimal place. Now, we're going to be using the addition formula for sine of x plus alpha. Now, remember, this is our a, this is our b. So the addition formula, now you can do r of all of it and then multiply each one by r, but I'm just going to multiply it all by r. So we know then that r sine of x plus alpha equals r sine a, which is in fact x, cos b, which is in fact alpha, plus r cos a, which is x, sine b, which is alpha. Okay, so I've already done that. Then I have a look. What I'm going to do is something called comparing coefficients. So if I have a look here, I have 3 sine x. So that means if I compare that to 3 sine x and I compare that to where we have sine x, we have r sine x cos alpha. Well, if I compare that, they both have a sine x. Perfect. And then this one has 3 and this one has r cos theta. So that must mean that 3 equals r cos sorry, not theta, alpha. Okay. And then I can do the exact same. If I have a look at 4 cos x, and I compare it with this one, because we have a cos x, we have r cos x sine alpha. So again, if I compare this, they both have a cos x, and then we have 4 and sine alpha. So that must mean 4 equals sine r sine alpha. So we know that r squared sine theta alpha plus r squared cos theta alpha equals r squared. And how do we know that? Because sine squared x plus cos squared x equals 1. So if I multiply everything by r squared, I'm going to have r squared sine squared x plus r squared cos squared x equals r squared. Okay, remember, if you're multiplying everything by, we're multiplying by r squared because r squared is a positive number. Okay, and if we multiply everything by a positive number here, we're not going to change the function, and we're not going to change the function at all. Okay, so all we're doing is stretching it. So then, using the fact that r squared sine squared alpha plus r squared cos squared alpha equals r squared. So we know that 3 equals r cos alpha from here. So if I square this, I'm going to get, so we're going to have r sine squared alpha, nope, we're going to have r sine alpha squared plus r cos alpha squared equals r squared. We know that r sine alpha is in fact equal to 4. So we're going to have 4 squared plus our cos alpha equals 3. 3 squared equals r squared. So that means r is in fact the square root of 4 squared plus 3 squared, which is 5. Okay. Now for the next step. So step 4, using the fact that r cos sine theta over r cos theta equals tan theta. Okay, so we know that r cos theta is in fact 3 and r sine, sorry, not theta, alpha. So that must mean that tan of alpha equals 3/4. So we can, alpha is going to then equal 53.1 degrees to 1 decimal place. So now I have all my information that I need. I have r, which is 5. I have alpha, which is 53.1. I can now write it in this form. So there we go. R, which is 5 sine of x plus 53.1 degrees. We have now written, this is what 3 sine x plus 4 cos x is equivalent to. Now, why do we do this? So we do this to help us solve, because we've written it as a single trigonometric function. So this is going to help us to solve. So sometimes if we have 3 sine x plus 4 cos x, no matter how much manipulation, it's going to be quite difficult for us to then solve it. I mean, you could, you know that cos of x is the square root of 1 minus sine squared x, and you could substitute that in here, but it just gets a bit messy. This is a really nice way to then to be able to solve this type of equation.
It's always good to check, isn't it?
So, give it a go. Follow the steps and pause it here and test your understanding.
Okay, so here we go then, step by step. So step 1, we want it in the form r sine of x plus alpha in terms of pi, okay? So we know that r sine x plus alpha, using the addition formula, is going to be r sine x cos alpha, remember because this is your a and b, yeah? And then it's plus r cos x sine alpha. Okay, and I've multiplied both terms by r because it's multiplied by r here. Okay, now what we're going to do is compare coefficients. So here I have sine of x. And here I have r sine x cos alpha. So if I compare this is 1 multiplied by sine x. This is r cos alpha multiplied by sine x. So I'm just going to write this down. So this can be rewritten as 1 multiplied by sine x. This can be written as r cos alpha multiplied by sine x. So therefore, if we compare the coefficients, we both have a sine x, and then this is 1, and this is r cos alpha. So that must mean that 1 equals r cos alpha. Okay? So 1 equals r cos alpha. And then similarly, we can apply the same principle to the other side. Here we have 1 times cos of x. And here we have r sine alpha times cos of x. So if we compare coefficients, we have cos of x, and the coefficient of cos of x is 1. So that must mean that r sine alpha must equal 1. Okay? So then we have 1 equals r sine alpha. Okay? So that means that tan alpha equals, silly cow, which is r sine alpha over r cos alpha, which in this case is 1 over 1. So tan alpha equals 1. So how do we find alpha? Tan minus 1 of 1 is going to give us alpha. So our alpha equals, make sure your calculator's in radians, please. Okay, and then we get pi over 4. Perfect, so we know what alpha now equals, okay? We'll manipulate it. Okay, so we have our alpha. X is our unknown anyway. We have sine. We now need to find r. Okay, does anyone remember how we find r or why we find r? Okay, so I'm going to use a different colour. So using the fact that we know sine squared plus cos squared equals 1, okay? That should mean, so using this principle, we know that we could then write this squared plus this squared, okay, should in fact equal r squared. Because what's the difference between cos alpha and this? First of all, we've multiplied it by r, okay? And if I multiply everything by r here, I now have r, okay? So I multiply everything by r first, okay? Then I square everything. So we're going to have r sine squared plus r cos squared equals r squared. So that's going to lead me to r squared sine squared alpha plus r squared cos squared alpha equals r squared. Okay? Now we already know what r cos alpha is, and that's 1. So we're saying 1 squared plus 1 squared equals r squared. So 1 squared plus 1 squared equals r squared. So r equals the square root of 1 squared plus 1, which is 2. So now I have all the information I need. I have alpha equals pi over 4, and I have r equals root 2. So for the last step, I fill in. So r, which is root 2, sine lots of x plus our alpha, which is pi over 4. And all I've done is rewritten this expression in this form. For example, you know when you have a quadratic and we complete the square? Yeah? The quadratic is still the same when we complete the square. We're just rewriting it as something else. And the reason why we rewrite it in this form is that so it's easier for us to solve with the knowledge that we have in pure 3. So that's what we're doing. We're manipulating this equation and changing it into this form. They still mean the exact same thing, but now we are able to solve this, okay? Right, so for the second question, we have put sine x minus root 3 cos x in the form r sine x minus alpha. So our objective here is to find r and to find alpha, and again it's in terms of pi. Okay, so on page 71, step 1, we're going to rewrite r sine of x minus alpha, and we're going to write that as sine x cos alpha minus cos x sine alpha. Okay, we should all be happy with that. And then we've got, and we're going to write an r because we multiplied everything by r. So we've got in our equation sine x multiplied by 1, and then we have cos x multiplied by root 3, okay? We compare coefficients, so they both have a sine x, so that means in this case r cos alpha equals 1, so that's our first thing, so r cos alpha equals 1, and then on the other side of the equation they both have cos x, so that means r sine alpha equals root 3, because that's the coefficient, yeah? So we're going to have r sine alpha equals root 3. So now, what can I do to find alpha? Well, I know if I divide them by each other, I'm going to get tan of alpha equals r sine alpha over r cos alpha. So we know that the two r's are going to cancel. And then we obviously know that sine alpha over cos alpha is tan alpha. Okay, so again, I'm going to have root 3 over 1. So tan alpha then equals root 3. So alpha equals tan to the minus 1 of root 3, and we're going to use radians. So in this case then, alpha equals pi over 3. So check. So we found our alpha. Now we need to find r. Okay, and using the fact from earlier, so in the exam, just so you know, to find alpha, I would always state my coefficients. So I would write this part. And then I'd write tan alpha equals this, okay? And then obviously we would have what alpha equals, okay? Perfect. Now I need to find my r. And again, it's using the fact that it's going to be, I know that r sine alpha squared plus r cos alpha squared equals r squared, okay? So I'm literally just going to do the square root of this squared plus this squared, okay? So I'm going to have the square root, so I know that r equals the square root of 1 squared plus root 3 squared. Okay, now 1 squared is 1, root 3 squared is 3, so this is actually root 4. Okay, when the square root of 4 is in fact 2. So now I have what r equals. My last thing is to write it now in this form. 2 sine x minus our alpha, which is pi over 3. And there we go, finished. Okay, so it's just about learning this method. I mean, understanding why, I've spoke to you about how we're manipulating it and how we use the knowledge of what tan is and that sine squared plus cos squared equals 1 to manipulate this. But it's remembering this method so that, and understanding why we do it so that then you can use it.
Okay, so here are the answers. Did you make sure you follow the steps? Again, these are the kind of minimum steps you need to write down. Please let me know if you need any more help.
Yeah, and we got it right.
Right, and now we have further examples, which I'm going to go through. So, put 2 cos theta plus 5 sine theta in the form r cos theta minus alpha, where 0 is less than alpha is less than 90 degrees. Hence, solve the equation where this equals 3. And again, this is what I was speaking about earlier. Once we put it into the form r cos theta minus alpha, we're going to be able to solve this equation a lot easier. So here we go. So we know that by comparing coefficients, we know that r cos theta minus alpha using the double angle formula is going to equal r cos theta cos alpha plus r sine theta sine alpha. Now, equating coefficients, we have cos theta, so r. So if I compare 2 cos theta by r cos theta cos alpha, I'm going to have 2 equals r cos alpha. And then for sine, I'm going to get 5 equals r sine alpha. So now, using r squared cos squared plus r squared sine squared equals r squared, I'm going to have the square root. R is going to equal the square root of 2 squared plus 5 squared. So r equals root 29. Then we're going to have tan alpha equals sine over cos, which is 5 over 2. So that means alpha equals 68.2 degrees. Right, so now I'm going to rewrite this. So we're going to have we know what r is, it's root 29. So root 29 cos theta minus 68.2 degrees. Okay, now we have that. We know this equals 3. So I'm going to rearrange. So I'm going to have now that cos of theta minus 68.2 degrees equals 3 over root 29. When I have a look at 3 over root 29, you have to remember now this is slightly different to when we have the interval when we're multiplying. So now we have 0 is less than theta is less than 360. Now we have theta minus 68.2 is less than. So on the if we minus 68.2, we've got minus 68.2, and then 360 minus 68.2 is 290. 1.8, 8.2. No, wait there. 292.8. Nope. 291.8. Perfect. So this is our new range of values for when we're using the cast. diagram. Okay, so when I inverse, I'm going to get theta minus 68.2 equals minus 56.1 degrees. Okay, so this is 56.1. Here we have 56.1. Right, so if I really think about what's going on here now, this is at 0, and the first time I cross is 56.1. Okay, so I'm going to write that down. Then I go all the way round and I cross here. Remember, this is 360 minus 56.1, which is going to give us, 303.9. But 303.9 is not in our interval, so we don't need that one. We're going to reject it. But we do go back to minus 68.2. Now, lucky for us, it gave us the negative anyway. But normally, then I'd go at 0 and I'd go backwards. And this would give us a minus 56.1. So, I only have 2 solutions for this. And then now I need to add 68.2 to both sides. So I'm going to get 12.1 degrees and 124.3 degrees. And that is our final answer. So now I really want you to give this one a try. So find the maximum value of 12 cos theta plus 5 sin theta and give the smallest positive value of theta at which this arises. So a bit of a clue. Please make sure that we have cos and sine. So you can use either r sine alpha plus theta, or you could use r cos, theta minus alpha. Okay, so you can decide whichever one you want. Then you have to think about what is going to give you the maximum or the maximum. So for example, that if you were to choose cos or sine, but if we choose cos, we know that cos of x has a maximum at 1. Okay, and the same with sine. Okay, they both have a maximum of 1. So if you had used r cos of theta minus alpha, cos of x has a maximum of 1 because it's 1 lot of cos of x. So it would now going to have a maximum. It would now have a maximum at r. And same if you did sine. If you just used sine of x, this would now have a maximum at 1. So if you did r sine of x, it would now have a maximum at r as well, because we've multiplied the function by r. So if you know the maximum is at r, you also need to think about, well, when does the maximum occur? For cos, we know the maximum occurs when x equals 0. And for sine, we know the maximum occurs when x equals 90, if we're working in degrees, okay? So in either case, once you've put it into this formula, you know the maximum occurs when x inside the bracket for cos equals 0. So you'd put theta minus alpha equals 0, and then you'd find what theta equals, which you would find in this case would be the maximum would occur at plus alpha. So if we're looking at cos, the maximum occurs at alpha 1. Then if we're looking at sine, it's going to be when theta plus alpha equals 1. 90. So we know that our x coordinate is going to be 90 minus alpha, and our maximum is 1, which is r. Okay, so it wants the smallest possible theta value. These are just the coordinates, but the smallest possible theta value for the maximum is either going to be alpha or 90 minus alpha, depending on which maximum. 13 should be the maximum for both. Is it 90 minus alpha? Right, well, try both ways and see what you get. So the answer is 22.6. So give that a go. Let me know how you get on. Right then, so we're going to have some quick fire of the maximums. So we know the maximum of sine theta is 20, and the smallest possible value is 90 degrees, because if you think about the curve, this always occurs at 90. And then for cos, 270, 0, 360. Remember, we want the smallest possible value. So really, we're just looking. So 5 minus 10 sine theta. Okay, so inside or outside the bracket? Outside. We've multiplied everything by minus 10. Okay, and then we've added 5. So our minimum is going to reflect. So now, think about the graph now. If I multiply, this is now going to be, we're going to reflect it because I've multiplied it. This is then going to be 10, but then I've added 5. So this is now 15, and this is going to be at 270. So the maximum is at 15, and the smallest possible value, the first time this occurs, is at 270 degrees. Because here, our maximum is going to be 3. Okay. And this is theta plus 20, so we're going to take away 20. So that means this is going to move here. So our smallest positive is actually going to be 360 plus minus 20, which is 340 degrees. Okay, so we've got a bit of a challenge for the last one. Do you think you can do it? Have a go, and then let me know. Okay, so I really want you to further test your understanding, okay, and have a look at what we could do here. So, first of all, express 6 cos theta plus 8 sine theta in the form r cos theta minus alpha, okay? So, express it in that form and make sure that your alpha is 3 decimal places. Then for part B, you're going to calculate the maximum value. Now here you have 6 cos theta plus 8 sine theta, which was used in question 1. So please rewrite that as r cos theta minus alpha. From there, you'll be able to find your maximum, okay, and the value of theta at which the maximum occurs. So give that a go, please. Answers are here. Let me know what you got. So please can you now do question 7, question 9, question 10, question 12, and question 15. Okay, and then the last thing is we're going to be proving trigonometric identities. So then, prove that 2 tan theta equals 2 over cot theta minus tan theta. So, what we're going to do is make sure that we use the appropriate double angle formula or addition formula. So tan of 2 theta, so left-hand side, equals tan of 2 theta. Now, using the formula, we know this equals 2 tan theta over 1 minus tan squared theta. Okay, not really sure where to go from here, but what I need to do is look at the question. So it's 2, okay, and if I look at here, how have they gone from 2 tan theta to 2? They've divided by tan theta. Okay, well, let's see, what's 1 divided by tan theta? Ah, that does give me cot theta. And tan squared theta divided by tan theta will give me tan theta. Okay, nice and easy. By comparing my answer to what I've done, I now know they've divided everything by tan theta. So because we have to prove, I need to show that step. So I'm going to write divide tan theta, and then I'm going to show it. So 2 tan theta over tan theta, all over 1 over tan theta minus tan squared theta over tan theta. So now I'm going to have the tan thetas cancel, which is going to give me 2 over 1 over tan theta equals cot theta. Okay, and I might even just write that. And then tan squared theta over tan theta is just going to give me, sorry, that's a minus tan theta, which equals right-hand side, therefore proved, okay? And because it's an identity, you can put 3 lines. Okay, next one. So we're going to prove that 1 minus cos 2 theta over sine 2 theta is equivalent to tan of theta. Okay, so I'm not sure which double-angled formula to use yet for cos of 2 theta because there's 3. Okay, so I'm just going to quickly write down sine of 2 theta. There's only one double-angle formula, so I have 2 sine theta cos theta. Oh, before I do that, sorry. Right, left-hand side equals 1 minus cos of 2 theta over sine of 2 theta, which equals sine of 2 theta. I know the double angle formula is 2 sine theta cos theta. Okay, now remember I'm trying to get to tan. Now with the cos double angle formula, so we have cos 2 theta equals, there's 3 of them. There's 1 minus 2 cos squared theta, 1 minus 2 sine squared theta, and I can't remember the other one. It has a cos squared theta and a sine squared theta in it. Oh, it's cos squared theta minus sine squared theta. Okay, so if I think about it, how do I get tan? Silly cow. So I want to get rid of the sine, and I want a sine over cos. Okay, so cos 2 theta. If I want to get rid of the sine, I'm going to have a sine squared, and I want a sine and a cos. Okay, yeah. I'm going to go for 1 minus 2 sine squared and hope for the best. So 1 minus bracket 1 minus 2 sine squared theta, okay, which is going to equal 1 minus 1 plus 2 sine squared theta over 2 sine theta cos theta. Okay, 1 minus 1 cancels, so I'm then going to have, oh, and 2 divided by 2 is going to cancel. So I'm now going to have sine squared theta over sine theta cos theta. Sine squared theta I can rewrite just to show you, but I wouldn't do this in the exam. Sine theta, which we know is then going to cancel. which is going to give you sine theta over cos theta, which is tan theta, therefore proved. Now, the more provey questions we do, the more you're going to know which one to substitute in and which one's going to work for the manipulation that we want. So, I want you to test your understanding and give these a go. Now, these are from the OCR exam board. So I know we're not with OCR, but they are some good questions. Now, just give it a go and see how you get on. And remember what you're trying to achieve. So remember what cot x is. And if you've got, you're trying to show that cot 2 of x plus cosec 2 of x is completely equivalent to cot of x. Okay? Then for the second one, by writing cos of x equals cos of 2 times x over 2. So this is actually a double angle formula because we're doing 2 lots of something. So this is cos 2a, okay? And your a is x over 2 in this case. Okay, so they've given you a clue. Please try your best. Okay, so here are the answers. How did you get on? These are the absolute minimum steps required for these provey questions. So please do not miss out steps. Pause it now so you can see the answers. Now what I'd like you to do is go to on exercise 4F, if you could complete question 4, 6, 8, 9 and 10.
So, question 6, we've got to show that question. So we need to show that cos 4 theta is 3 over 8 plus a half cos 2 theta plus 1 over 8 cos 4 theta. Okay, step 1. Now, again with these questions, you never know what's going to happen, okay? So I'm going to look in if you go to page, in the book, if you go to page 96, we have a summary of all the formulas, okay? So page 96, we've got the addition, we've got double angle, and we've got the R sine or R cos, okay? So keep on page 96 while you look at this. Now the first thing really I see that I've got a double angle formula, okay? And I've got a double angle formula twice, really. Well, 3 times, right. This is what I'm going to do. I have no idea if this is correct, but I'm going to roll with it, okay? An intuition. I want cos to the power of 4. So I'm going to use the double angle formula here, and I'm going to use the one that just has a cos squared in, okay? And the same, I'm going to use a double angle formula here. Now, I always write down what formula I use on the side. I just think it's good practice. So I'm going to be using cos of 2a equals 2 cos squared a minus 1. Because I want to get cos to the power of 4. So I'm, logically, why would I substitute in the one that says cos and sine? Because I know that even though cos equals the square root of 1 minus sine squared, it's just going to get messy, okay? So number 1, intuition. Number 2, let's really think about this. So cos of 2 theta, we know is going to then become 2 cos squared alpha minus 1. So I'm going to have 3 over 8 as normal, plus a half bracket. And then instead of cos of 2 theta, I'm going to write 2 cos squared theta minus 1. Okay, straight substitution. Okay? And then I'm going to have plus 1 over 8. And I'm going to substitute again, but imagine, so I've got 4 theta. Okay? So this means that my A is now 2 theta. Okay? So I'm going to put that in. So then I'm going to have 2 cos squared 2 theta minus 1. Right, I'm going to expand out everything first. Okay? So I'm going to have 3 over 8. And then a half times 2 cos squared theta is in fact cos squared theta. Oh, sorry. And then I'm going to have a half times -1 is minus a half. Okay, everyone should be happy with this first expansion. Then the second expansion. 1/8 times 2 cos squared 2 theta. So 2 cos squared 2 theta is going to give me it's a quarter, yeah? Plus a quarter cos squared 2 theta minus an eighth. Okay, so here I am. Right, I'm just going to sort this out a little bit. 3/8 minus an eighth is 2/8, which is a quarter, minus a half. I think I'm going to get negative a quarter. Plus cos squared theta plus a quarter cos squared 2 theta. So this is where I'm at. Okay, now what I'm going to do, I'm going to look at these formulas again and see if there's anything I can do. Right, cos squared 2 theta. So, cos squared 2 theta, okay, actually can be written like this. Cos of 2 theta all squared. Okay, again, we have another double angle formula, and I'm going to substitute this one back in again. So let's see. So now I'm going to have plus a quarter of 2 cos squared theta minus 1 all squared. And then obviously I have my minus a quarter cos squared theta. Okay, great. So now what do I have to do? So now I've got to expand this bracket. Okay? So now I'm going to have 2 cos squared theta minus 1, 2 cos squared theta minus 1. And then obviously I'm going to multiply the whole thing by a quarter after, okay? But let's just forget about that for now. So when we expand the bracket, 2 cos squared theta times 2 cos squared theta is 4 cos to the power of 4 of theta. Minus 1 times minus 1 is plus 1. Minus 1 times 2 cos squared theta is minus 2 cos squared theta, and then 2 cos squared theta minus times minus 1 again is minus 2 cos squared theta. Okay then. Now this is going to give me 4 cos 4 to the power of theta. Oh, that's a plus. Plus 1 minus 4 cos squared theta. Okay, is everyone happy? That's what it expands to. Now we're going to multiply it by a quarter, aren't we? So, now if I bring all this down, I'm going to use a blue pen. So we have minus a quarter plus cos squared theta plus, and now I'm going to do a quarter times this whole bracket. A quarter times 4 cos to the power of 4 theta is just cos to the power of 4 theta. A quarter times 1 is a quarter, and a quarter times minus 4 cos squared theta is just minus cos squared theta. Okay, this is really good, everyone, because guess what now? Minus a quarter plus a quarter is going to cancel. Cos squared theta minus cos squared theta is going to cancel. And what are we left with? Cos 4 theta, which equals the left-hand side. Therefore, proved. Oh, right-hand side equals. Okay? So, remember, this is a 6-mark exam question, okay? And the only rule that I've used is this double angle formula. And I've just kept substituted it in until it makes sense. Now, this is where your intuition really comes into play, okay? And sometimes you do go wrong, and sometimes you think, oh, but is that right? But again, you've got to remember that cos squared of 2 theta can be rewritten as cos of 2 theta all squared, okay? So, okay, step 1. Use your intuition, okay? And you think you've got cos to the power of 4, and then you've got 2 theta and a 4 theta. So you've clearly got some double angle formulas, yeah? So, I look at the double angle formula. Cos to the power of 4, I can't do anything with that. I don't really know any rules that are going to help me, so I know I'm not going to start on that side. I'm going to start on the right-hand side. And I've got a double angle formula, but because I want a cos to the power of 4, I'm going to find the double angle formula which just has cos in it. Okay, because there's no point putting sign. So it's like a hunch. Right. Now, I have 3 over 8, 3 over 8, plus a half. Instead of writing cos 2 theta, what am I going to do? I'm going to substitute this in. Okay? So I'm going to substitute in 2 cos squared, and then here I need to half that to get my a, because remember this is double it, isn't it? So half of 2 theta is just theta minus 1. So I've substituted that in here. So instead of cos 2 theta, it's 2 cos squared theta minus 1. Okay? Then I've got plus 1 over 8. Now here I've got cos 4 theta. I know if I half that, that means my a in this case is 2 theta. Okay, so I've used the same formula, but I've got my 2 theta. So I've got 2 cos squared 2 theta minus 1. Okay? Now, I expanded all my brackets. So 3 over 8, check. A half times 2 cos squared theta is cos squared theta. A half times minus 1, minus a half. 1 over 8 times 2 cos squared 2 theta, a quarter cos squared 2 theta. 1 over 8 times minus 1, minus 1 over 8. Okay, perfect. I'm now here. I'm now looking at this thinking, how on earth am I going to get anywhere? No idea yet. So all I did in the next step was simplify. I had 3 over 8 and minus a half and minus an eighth. So I just simplified all my numerical values, okay, which gave me minus a quarter. And then I had a cos squared theta here, and then I had a quarter cos squared 2 theta here. Now I'm looking at the formulas I've got, and none of these have got a squared in. And then I remember, okay, that cos squared 2 theta is actually, can be written as cos of 2 theta all squared. That's what it means, isn't it? So if you knew that cos of 2 theta equals 4, well, cos squared of 2 theta would be 4 squared, okay? So, with this, knowing this, I now know that cos squared 2 theta, okay, can be written as cos of 2 theta squared. Cos of 2 theta is 2 cos squared theta minus 1. So I substituted that in here, okay, and then I squared it. Okay? Then I've done 2 cos squared theta times 2 cos squared theta, 4 cos to the power of 4 theta. Minus 1 times minus 1, plus 1. Minus 1 times 2 cos squared theta, minus 2 cos squared theta. 2 cos squared theta times minus 1, minus 2 cos squared theta. I then simplified this, minus 2 cos squared theta, minus 2 cos squared theta, minus 4 cos squared theta. Okay? So I now have 4 cos 4 theta plus 1 minus 4 cos squared theta. That is what this equals. I'm now going to multiply it by a quarter. Okay? So a quarter times 4 cos 4 theta is cos 4 theta. A quarter times 1 is a quarter. A quarter times minus 4 cos squared theta is minus cos squared theta. And then I brought this down. So I'm going to, if I rewrite this in, so I'm going to have here minus a quarter plus cos squared theta plus a quarter of this bracket. Okay, that's what happened. I brought that down. Okay? And then there's like a little step in here This little step in here is here, okay? Then, lastly, I simplified it. Minus a quarter plus a quarter is 0. Cos squared theta minus cos squared theta is 0. And then I'm left with cos to the power 4 of theta, which equals my left-hand side of the equation. Therefore, proved.
And then finish off with a final challenge for you. Please pause it now. I'm not going to give the answer to this challenge, and let's see who completes it.